In this video, we're going to use the 45-45-90 rule and the 30-60-90 rule to find exact values of some trig functions. So, our first example, I want to find the exact value of cosine of 210 degrees. Now, we said previously that the input, the angle we put inside a trig function, we think of as the interior angle of a right triangle. So 210 is a little big. That's not going to be inside of a right triangle. But to handle this, what we're going to do is use its reference angle. So first, I'm going to go off and draw 210 degrees in standard position, and then find the reference angle for 210 degrees. So I'm drawing the Cartesian plane. I know 180 makes a line, another 30 would get me to 210. So my angle should look something like this. I'm going to draw the terminal ray. This is 210 degrees in standard position. Now, that terminal side has a reference angle. The reference angle is always formed by the x-axis and the terminal side, that angle right there. I can calculate that. 210 minus that 180, this is a 30-degree difference. So 210 has a reference angle of 30 degrees. And we found trig functions like this. I'm going to raise up a perpendicular, creating a right triangle. And then, how to handle this situation? Well, I do have a 30, 90, therefore 60 triangle. And I'm trying to find the cosine value. Cosine is the x value divided by the radius, or the r value. So that radius, or that r, is the radius of some circle. May not need a circle, but that's just drawing it to help me visualize what's going on here. Now this relationship, x over r, this is a ratio. So if this were 2 to 1, that's the same thing as 4 to 2, which is the same thing as 16 to 8. The numbers aren't necessarily important. It's the ratio that is important. So what I'm going to do to help me out is I'm going to let the radius of this circle be 1 unit. It's almost like I could measure this off, and maybe when I measure it, this radius measures 12 inches. Okay, I'm going to call that 1 foot. So whatever the radius measures, I'm going to just let it be 1 unit. If you have a circle with a radius of 1 unit, we call that the unit circle. We're going to talk about that a lot more. But a unit circle is a circle with radius as 1 unit. Alright, so if the radius is 1, then I think I can use the 30-60-90 rule to figure out x and y, the other side lengths of the triangle. In fact, let me kind of zoom in on that triangle. There's my 30-degree angle, there's my right angle, there's my 60-degree angle, and I'm letting the radius be 1 unit, and then I'm going to use the 30-60-90 rule to figure out the other two side lengths. The rule says the shorter side length, the one I want to call y, is always equal to the hypotenuse divided by 2. So this y value is a half. The length of it is 1/2. Now remember, all students take calculus. This is in quadrant 3, so that y value is a negative 1/2. Then the x side length, which is the larger side length, is simply that shorter side length being multiplied by the square root of 3. I'm going to call that negative root 3 over 2. So if I want to find cosine of 210 degrees, I'm going to use, it draws this situation up for us. And cosine of this reference angle would be the x value over the hypotenuse. So cosine of 210 degrees uses this reference angle. This reference angle has an x value of negative root 3 over 2 and a radius of 1, or simply negative root 3 over 2. Cosine of 210 is negative root 3 over 2. Let's do that again. Let's find sine of, well, I'll do some big number like 405. All right. Well, 405, what I'd like to do is draw that in standard position. And what I'm really looking for now is a reference angle for 405 degrees. Cartesian plane. 360 plus another 45 will get me to this 405 degrees. The reference angle is this positive acute angle formed by the terminal side and the x-axis. It has a reference angle of 45 degrees. I'm going to draw a triangle using this terminal side. Oh, so I've got a 45, 45, 90 triangle. And like in the previous example, I'm going to let the radius be 1. Well, if I know one side length of a 45, 45 right triangle, I can find the other two side lengths using the rule. That rule says up there that the sides, x and y, they're going to be equal, and they're going to be equal to the hypotenuse divided by the square root of 2. So 1 divided by the square root of 2. I think I'll rationalize. Multiply top and bottom by the root of 2. So the side lengths are equal to the square root of 2 over 2. And if I'm looking for the sine value, sine is defined as y over r. So using my reference angle of 45, sine of 405 degrees is equal to the y value, root 2 over 2 over the radius. But over 1 is just going to be that y value. So sine of 405 degrees is the square root of 2 divided by 2. Let's try a quadrantal angle, or non-quadrantal angle, that lies in quadrant 2. So let's do another example, tangent of 150 degrees. Let's do another example where we're in quadrant 4. So how about secant of, let's do 300 degrees. If you want to pause the video, now is a good time to try to find these exact values using the rules mentioned. For both of these examples, I need a picture. I'm going to draw 150 degrees, and I'm going to draw 300 degrees. (150) is 30 shy of 180. (300) is 30 more than 270. Both of those angles have a reference angle. We always draw the reference angle from the, from the terminal side to the x-axis. The angle from the terminal side to the x-axis. So there's my little theta. On the first example, it's sitting right there. Now those reference angles are the interior angles of a right triangle. So I'm going to draw a little right triangle. And notice I wasn't given any values. I wasn't given an x value, a y value, or an r value. When I'm not given any values, then I can make the triangle however big I want to. I just chose to put it here, and then I'm going to say, you know what? This radius looks like 1. This radius over here looks like 1. I'm only allowed to do that if there's no other information given. In the previous examples, in the previous videos, we were given things like a coordinate pair. Well, that's an x value and a y value. That's going to have a radius that's set in stone. 3, 4, 5. The radius was 5 in that example. Here, we're just trying to find it in general. So I'm using this idea of a unit circle where I just let the radius of the circle be 1 unit. And then, for both of these, I think I'm going to be able to use the 30, 60, 90 rule. Because this reference angle is 30 degrees. This reference angle is 60 degrees. So for both of these examples, they're 30, 60, 90 right triangles. All right, I want to find the y and the x, just for fun. Tangent needs both y and x. Secant just needs x and r, so I wouldn't have to find y. But it's probably good practice just to find it out. All right. In a 30, 60, 90 right triangle, I have the rules sitting right there. The shorter side y will be equal to the hypotenuse cut in half. So in the first example, y is equal to 1 over 2. Then the longer side length x is equal to that shorter side times the square root of 3. Which I'm just going to call the square root of 3 over 2. I'll find an xy for this example. The shorter side length in this example is x, so it's 1/2. And the y value, the larger side length, will be the root 3 over 2. Now let's not forget the all students take calculus. Y is positive, but x should be negative. This is a negative root 3 over 2. In this example, the x is positive, but the y value is negative. The y value is below the x-axis. It should be negative. I think I'm safe to say now, tangent of 150 degrees is defined as the y value over the x value of this triangle using the reference angle 30 in quadrant 2. And that's going to be 1/2 divided by negative root 3 over 2. Some of you may want to keep, change, flip. I'm going to simply multiply by 2 over 2. That's going to help me reduce this. I get a negative 1 over the square root of 3. I'm going to rationalize the denominator. I get negative root 3 over 3. Tangent of 150 degrees is negative root 3 over 3. Secant is defined as the radius over the x value. So secant of 300 degrees, which is referring to this situation, is equal to the radius over the x value, 1/2. Similarly, you may want to keep, change, flip. I'm going to multiply by 2 over 2 and end up with 2 in the end. So secant of 300 degrees is a lovely number, 2. All right. So you should now be able to take a circle and along every 30 degree and 45 degree interval, go along and label all of those coordinates. So it may take a while, but if you have like 45 degrees, if I were to draw a triangle at this 45 degree, we already know the information from this triangle situation right here, where the x's and y's are the same. They're both the square root of 2 over 2. So this x coordinate is the square root of 2 over 2, and the y coordinate is the square root of 2 over 2. And we're letting, in this case, all of these radii just be 1 unit. But I claim you can do this the homework now. I'm going to give you degrees that are multiples of 45 degrees or the 30, 60 degrees, and you should be able to find exact values of those 6 trig functions. All right, go give it a shot, and I'll see you in the next video.